The first part of 7.1 was about the interior angles of polygons, and the second part is about exterior angles of polygons. Exterior angles are formed when you extend one side of the polygon and use the other side to form an angle. The thing I think of when I think about exterior angles is I think of a camera shutter opening and closing. The camera shutter would eventually close down to a single point, and the reason that is important is because all of the angles add up to 360 because the exterior angles form that single point. Just so we're clear about what the definition is, an exterior angle is formed if I extend one side of the polygon and then form an angle with the adjacent side. So this is the exterior angle at this vertex, and then the interior angle would be the angles that we talked about yesterday at that same vertex. At any vertex, the interior angle plus the exterior angle would sum to 180 because they form a linear pair. So at each vertex, I would extend the side out to form that exterior angle. And each one of those exterior angles would form a linear pair with the interior angle that is adjacent to it. So these are two examples of trying to find the sum of the exterior angles in a diagram. This one is a pentagon. It has 108 degrees at each of the interior angles, which means that each of the exterior angles is going to be 72 degrees at each of the exterior angles. And there are 5 of them, so 72 times 5 would give me 360 degrees. So the sum of the exterior angles for this pentagon is 360 degrees. I can do something similar for this quadrilateral, this 4-sided polygon. Each of these angles have to add up to 180, so those exterior angles are 90. This exterior angle is this interior angle is 116, which means the exterior angle would have to be 64 degrees to make it add up to 180 degrees. Meanwhile, the sum of the interior angles, because it's a quadrilateral, should be 360 degrees, because that's 2 times 180, because there are 2 triangles inside of that shape. So that means that the interior angles, 90 plus 116, plus this one we don't know about, has to equal 360. 90 plus 90 is 180, so that means that 116 plus x has to equal 180. I just subtracted 180 from both sides of the equation. And then if I subtract 116 from both sides of the equation, I get 64. So this missing angle is 64 degrees. And that means that the linear pair next to it, the exterior angle, is 116 degrees. And then if I add up these 4 exterior angles, 90 plus 64 plus 116, I get 360. And that turns out to be maybe a little bit surprising, but it turns out that every polygon has a sum of exterior angles of 360 degrees. We can go back to thinking about that camera closing up. Again, it would close up into a single point, so all of the angles around that camera lens would add up to 360 degrees. So the sum of exterior angles in a polygon is 360 degrees always. So we have some practice problems for 7.1b, and I'll have you pause here so that you can try the problems before I do them with you. So number 1, find the sum of the exterior angles of a 13-gon. I don't care how many sides it has, the sum of the exterior angles will always be 360. Number 2, what is the measure of one exterior angle of a regular octagon? Well, the sum is 360. If it's a regular octagon, they'll all be the same size, so I'm going to divide by 8. So one exterior angle is 45 degrees. And then number 3 is about this regular polygon, which has 9 sides, so it's called a nonagon. The sum of the interior angles is going to be 180 times 9 minus 2, or 1,260 degrees. If I want the measure of one interior angle, I do 1,260 divided by 9, which is 140 degrees. And then sum of the exterior angles, that's 360 degrees always. I don't care how many sides you have. And the measure of one of the exterior angles is going to be 360 divided by 9, because they're all the same size, which is 40 degrees. Or we know that each exterior angle forms a linear pair with the interior angle, so I could have also done 180 minus 140 to get that 40 degrees for the exterior angle. One more set of problems, actually 2 more sets of problems. Try these 2 and unpause the video when you've given them a try. Okay, for these ones I was given the measure of the exterior angle in a regular polygon. Since I know that it has to add up to 360, I did 360 divided by n, has to be 24. And then I solve for n, so n is 15, which means that this is a 15-gon. We don't have a special name for a 15-gon, we just call it a 15-gon. And then 2 ways that we can we can find the sum of the interior angles of the polygon. One way, we could find the measure of one of the angles by knowing that it forms a linear pair with that 24-degree exterior angle. So one of the angles is 156 degrees. There are 15 of them, so 156 times 15 gives you 2,340. The other way you can find the sum of the interior angles of a 15-gon is you can do 180 times 13 to give you 2,340 degrees. This other one, we have a exterior angle is 120 degrees, which means that one of the exterior angles, well, they all add up to 360, which means that there are 3 of those exterior angles. We have a triangle. One way you could find the measure of one interior angle is you could do 180 minus 120 because they form a linear pair. You get 60 degrees. The other way you can find the measure of one angle is you could do 180, which is the sum of the angles in a triangle, divided by 3, which gives you 60. These last 2 involve some problem solving, and I've posted my key for these on Schoology. Take a look at it, and have a good day. Bye.